This is transition of electron. What is transition of electron? Now one electron, if it is in a higher state, higher energy level, if it is coming to ground state, then it will emit a photon. What it will emit? Photon. This photon energy is h nu. Photon energy what? H nu. Or photon energy h nu. And here this energy level, this one you can give it E2, this is E1. Or this is basically higher energy level. This is a higher energy level, this is lower energy level. Higher energy level. This is your lower energy level. Lower energy level. Okay. So when electron comes from higher energy level to lower energy level, it will emit a photon. Okay. And that photon energy h nu, that is nothing but, that is equal to the energy difference. That is equal to energy difference. That is equal to what? Energy difference between the two energy levels. So the energy difference between the two energy level is nothing but E2 minus E1. Always remember, when energy difference we are finding higher energy level minus lower energy level. So what basically we found here? The energy difference. The energy difference between two energy levels. So between U1 and E2 you can tell, or directly write the energy difference is given by delta E, which is E2 minus E1. Higher energy level energy divided by lower energy level energy. Okay, E2 minus E1. Okay, and this lambda is nothing but what it is? Now nu is frequency of photon. Frequency of photon. And lambda is what basically? Wavelength. Wavelength of photon. Okay. So if a similar photon you give one electron in ground state, that electron will go to higher energy level. Same energy will give to one electron in ground state, that will go to what? From lower to higher it will go. Okay. Even lower energy state electron is there, if same photon energy you are giving to electron will absorb that energy, then it will go to. So when electron is absorbing energy, that is called absorption. When it is emitting energy, it is called emission. Okay. So due to absorption and emission, we will get some spectra, some lines. So that is called absorption spectra or emission spectra. Accordingly, absorption or emission. Okay. So now everyone understand here. From here, certain formula I want to find for hydrogen atom. Okay. So what we know exactly? We know now E2. If this is your n equal to 2, this is your n equal to 2 level, second orbit. This is your n equal to 1. N equal to 1, like that I am taking. Okay. Let me take like this. N equal to 2. N equal to 2 like this you take. Don't take equal to 2. N2 like this take. N1 take. N1 orbit. Let me write here also. This will be better. Let me write this is N1 orbit. N1 orbit. This is your N2 orbit. N2 orbit. Or N2 state, N1 state. Now E2 what I can write? Minus 13.6 electron volt divided by N2 square. And E1 what I can write? What is E1? Minus 13.6 electron volt by N1 square. Yes or no? I can write or not? So what you understood here? Your N1 is lower orbit. N1 is what? Lower orbit. And N2 is what? What is N2? N2 is higher orbit. Okay, N2 is higher orbit, N1 is lower orbit. And according to energy formula, total energy, E2, E1 I am writing. Are you able to get or not? Hello? En equal to minus 13.6 by n square. Instead of n square I am writing n2 square. And I am telling that is n2 orbit. What orbit? N2 orbit. Similarly, here also n square is there. I am writing n1 square. N1 is lower orbit, n2 is higher orbit. Now let's find the difference. Let's find energy difference. Now next listen. Did you complete this one? Write down. It's saying where that photon is coming. When electron is coming from higher state to lower state, it is emitting one photon. Energy is emitting in terms of photon. Okay? Yes or no? So transition of electron, everyone understand carefully. Clear? Shall I go to next page? You write please. Write first. Always when you find energy difference, always remember higher energy level energy minus lower orbit energy or lower energy level energy. Okay? Higher minus lower. You do like that. Clear all of you? Clear? Any doubt still? Okay. Now next listen. Next listen. Continue please. Now if delta E I want to write, that is E2 minus E1. Okay. Or delta is basically H nu na, H nu. And delta is nothing but you know already it is E2 minus E1 you wrote. It is SC by lambda. SC by lambda. Okay. Or can I write, let me write SC by lambda equal to E2 minus E1. Then SC by lambda equal to E2 is what? Minus 13.6 electron volt by N2 square. Minus of minus 13.6 electron volt by N1 square. Now right here minus 13.6 electron volt by N2 square plus 13.6 electron volt by N1 square. All of you listen. Your SC by lambda still it is there. Now I can take 13.6 electron volt out. Then I can write this one as 1 by N1 square minus 1 by N2 square. Now this is your SC by lambda. Now take 1 by lambda here. It will be 13.6 electron volt by Hc. This is nothing but 1 by N1 square minus 1 by N2 square. Now what I will do here, let us listen. 1 by wavelength equal to, this one I will write as R. R into 1 by N1 square minus 1 by N2 square. Lower orbit square minus 1 by higher orbit square. Now next listen. Where this R, okay, R is called 13.6 electron volt, its value, divided by Hc, or it is called Rydberg constant. What do you call? Rydberg constant. Its value will be, write down, theoretical value 1.03, but let's write here 1.09 into 10 to the power 7 meter inverse. This is the Rydberg constant. And 1 by lambda is nothing but, it is F bar. It is called wave number. It is called wave number. Everything remember. This 1 by lambda will use to calculate wavelength. Okay. N1, N2 value will be given. N1, N2 value will be given. Okay. So this all you remember. R value. And if you 1 by R value you are writing, you write it is 912 angstrom. 912 angstrom. These all are important. Remember everything. And N1 is lower orbit, N2 is higher orbit. Already you know. N1 is lower orbit, N2 is higher orbit. And this formula is very important. This formula 1 by lambda equal to R into 1 by N1 square minus 1 by N2 square. So when transition is happening for electron, then what we'll do? Now we'll use this formula to find wavelength of photons. Okay, either it is absorption or emission. Okay, but remember always higher orbit will be N2, lower orbit will be N1. So first you are doing what? First you are doing lower orbit square. Remember this 1 by lambda equal to lower orbit square. 1 by lower orbit square minus 1 by higher orbit square. Okay, clear? Now when you will study this line spectra of hydrogen atom, all the series, spectral series, that time this will help us. Okay, now we'll see that one. Previous page, okay. Previous page you check. Tell me what is energy difference? Higher energy minus lower energy or what? Lower energy minus higher energy. High energy minus low energy. Like that you do, then you will get energy difference. And what is 1 by lambda formula? Say, Jayakas, 1 by lambda equal to R into 1 by N1 square minus 1 by N2 square. What is N1? Lower orbit. And N2 is higher orbit. Remember that. 1 by lower orbit square minus 1 by higher orbit square. Now come to the next page. So note it down everything. Completed all of you? So E2 value I substituted here, minus 13.6 electron volt by N2 square. Then E1 value also, then minus became plus here. In this case here I am telling. Now then after 13.6 I took out and I wrote first 1 by N square, then minus 1 by N2 square. So wavelength of photon, how to find? Now 1 by lambda equal to R into this one. 1 by N1 square minus 1 by N2 square. N1 is lower energy level, N2 is higher energy level. Or N1 is lower orbit, N2 is higher orbit. And R is what? Now 13.6 electron volt by XII. That is called Rydberg constant. Its value is 1.09 or 1.1. You can take 10 to the power 7 meter inverse. Okay, thank you. I hope you understand everyone, no doubt, right? And if you 1 by R you need sometimes, you see 1 by R value is this much, 912 angstrom. Okay, getting boys? No doubt? Current? Okay, thank you. We'll go to next. Thank you all of you.